Okay, hello everybody. What we're doing now, I'm here in the Transformer Lab, and what I have set up is basically a rectifier lab setup. Now this is a three-phase half-wave rectifier circuit, and so I'm going to explain in just a moment what I have going on behind me there. Um, This transformer bench is the same bench that Jack is using as he's showing you the transformer connections. And so I'm using the same bank. And the reason we do that is to get exactly the right voltage level for the rectifier circuits that we're looking for. Now, the half-wave rectifier that I'm going to show you is based on 120 volts of phase voltage. Okay, because remember, with the three-phase rectifier, um, we're actually going from line to neutral. And so that line to neutral needs to be close to 120 volts. Now that means that my secondary line is going to need to be 208 volts. And so what I've done with the transformers that are set up just behind is I have started with 240 volts coming in from the line, and the transformers, the coils are 240 volts each on the high side. So I've paralleled them up. So I have 240 volts coming in there, and then I've taken my 120 volt coils and I've also paralleled them. Those are my X windings. And so what I have then, of course, is a 120 volt phase voltage on the secondary, and I'm connecting that in a Y. And that Y connection then gives me the 208 volts of line voltage. Now to that 208 volt line with a neutral, it's a 4-wire circuit, I'm connecting my half-wave rectifier. So I go one lead from each line into the diodes, and then I connect the 3 diodes together on the opposite end, and then I go from there to the load. Now, what I have here is in this lab is a 60 ohm load, as you'll note in the lab, and that 60 ohm load will now be DC voltage, and from the other end of the load, I go back to neutral. Now, I'm going to just show you where those connections are. I'll point them out to you. So, coming from up at the top here, this line up top, 240 volts. Comes down through these primary windings, which are in parallel, 240 volts of phase voltage. Here's the iron core in the center. These are the secondary phase voltages, 120 volts per transformer. I've connected them with neutrals to these lines down here. So down below, you're going to see my red, black, blue, and white. And so I have down here my lines all connected together. Now I've connected some meters, and so what I'm going to show you is the exact voltage. This is the line voltage that I have right now. Okay, so make sure you got no glare. 218.2 volts. Now remember, this is supposed to be a 208 volt line. So why is it 218? Well, it's because there's nothing else much going on in the labs, and so the actual voltage in the lab is a little bit higher than it would be if there was quite a bit going on. So if if there's a lot of people using a lot of machines, then you get a little bit more voltage drop. The transformers are loaded up a little bit more, and then it goes down to 208. But we're without too much activity here, there we sit at 218 volts. I think that's about 246 volts actually on the primary. So 218, and that's our Y connected line voltage. All right, set that one down. Now, I've also connected a meter from line to neutral. Do the perfect angle there, 125.7 volts. Now, in fact, this is the voltage, 125.7 is the voltage that is going to be connected across the actual rectifier, because remember, we go from line to neutral across that half-wave rectifier. So 125.8 volts is the phase voltage, line to neutral voltage. All right, let me show you through as much as you can see. These are the wires that come from A, B, and C lines. And what I have is, I'm just going to show you a couple of interesting things. Just bear with me for a second. I'm going to grab another piece of equipment. Okay, I'm back. Now take a look. What you're going to see, what you should see is right here, right at this point, you can see my pointer there. That's line A. This is right here is the diode in the A phase. Okay, this is line B coming in right here. And this is the diode in series with B. Right there's the diode. This is line C coming in right here. And there's the diode, of course, for C. Now, at the bottom end, now these, you'll see there's a fuse in series with each one, a fuse in series with each one of those diodes to protect them. Make sure if there's too much current, we don't burn the diode out. And at the bottom, what you're going to see is down here, these 3 points right there are just looped together with these conductors that you see right here. So we've just tied that together. This is the lead that goes, first of all, to this ammeter. And so I'll show you this right now. If you take a look and try and get that sort of in a good spot for you, that is 2.36 amps DC. 2.36 amps DC. And that's actually the load current. So that line comes from the bottom of the diodes, comes into this meter, out of the meter, and you should be able to see it. I'll point it out over on the side over here. See on the side over here where my pointer is, right over on this side. This is actually the load. These bottom two elements right here are the load elements, and they're 30 ohms each for a total of 60 ohms, okay? So that's the load. And so I have the current that's going through the load. Now let's take a look at the voltage across the load. And let me just show you this meter right here. Now this is the DC average voltage. DC average voltage. 144.9, one say 145 volts DC. Now that's the actual load voltage being fed from this rectifier. Now the interesting thing is, now think about this, the phase voltage that we're applying to this is essentially 120 volts. I think it's around 125, right? How is it, this is really something, how is the load voltage actually higher than that phase voltage? And you should be able to think back to some of the theory we talked about now, and you say, yep, the actual, the phase voltage, whatever the phase voltage is, the average voltage is actually even higher than that phase voltage. Okay, and so we'll, you know, this will come back to you when you go back and look through your notes about the half-wave rectifier. 145 volts load voltage. Now, the most important thing of all, I've talked about this before, and the most important thing of all is what do we see on the scope? So I got to get the scope in a position where you can hopefully see it here. Yeah, that's not too bad. There's the scope right there. Now, what you're looking at is the ripples that start at 50% of the peak voltage, okay, about 50%. So in other words, from 0 to 50, you don't see any ripple, but watch what happens if I pull one diode out. There's 0 volts, okay? So you can see what 0 volts looks like. It's that bottom line. And get a little better grip on this because I'd hate to toss it on the floor. There we go. So you can see you've got 0 volts, and that's the bottom line. As soon as I plug this back in, you're going to see that jump back up, and sure enough, it fills in, and you can see that that's actually just the ripple voltage. Now, those 3 ripples per cycle are what are giving us that 145 volts DC. It's these 3 ripples out of the rectifier, and the average of those 3 is actually 45 volts. Now, what is the peak of that waveform? Well, just to let me remind you, this is being fed from a 120 volt phase voltage. So that means that the peak that you are looking at right there should be about 170 volts. About 170 volts. Now, if you pull one diode out, you'll see that in fact you lose quite a bit and the voltage is going to fall quite a bit. Now, I'm going to just bring this over. I'm going to move this to the side. And I want to show you this voltage right here. This is the load voltage now. So with one out, it's 104 volts. Now, if you're kind of going, this is like the joke where one engine goes out and the pilot says, well, it's going to take us a couple extra hours. What happens now if I pull out a second diode? So let's watch the scope. Now what do we have? Well, we have a cycle with just one ripple in it. And it kind of looks like a single phase sort of thing, doesn't it? And let me move to the side a little bit. And what do you see there for voltage? Look at that, went from 104 down to 55.5 volts. So the voltage just keeps dropping as we, as we reduce the amount of ripples. So 55.5 volts for one ripple. I'm going to plug that back in. 104 volts for 2 ripples, and 145 volts with 3 ripples. And so you can see that honestly, the average voltage just builds higher and higher as you increase the number of ripples. Now I'm going to set this scope down. Very, very interesting to see that effect on the scope. You can just stop that, Matthew. Okay, I'm back. I just, what I'm going to do is just take a few minutes now, and what I'm going to do is I'm going to take this board. It doesn't take very much. I just need to do a little bit of rewiring to hook this up for a full wave, rectifier. And so that's what's going to come up next. All right. So this one was the half wave, and moving on in the next clip, we're going to be moving on to the full wave 3-phase 6-pulse rectifier. Okay, coming right up.